Science time. Yes or no? Yeah, science time. Okay, what are we talking about?
Tectonic plates.
Yeah. Okay, we're talking about tectonic plates. Remember, tectonic plates are like puzzle pieces. You like puzzles, right? You like puzzles? Yeah, you like puzzles. So we're going to say these are our puzzle pieces, right? And they're supposed to fit together, and they kind of fit together, but they're not amazing at fitting together. And that creates all kinds of natural disasters because they're moving all the time. Okay? Remember before when we talked about heat and magma under the surface of the earth? Remember magma? Mm-hmm. You remember this? Should we turn on the video real quick so you can see the idea? Okay, sit up. So this is our magma. Is heat going up or down?
Up.
Yeah, heat goes up, right? So heat's going up. And then as it cools down, it starts to fall back down, right? And so it's going in a motion like this. It's going in circles and circles and circles. And that makes all the top of it move. There's lots of moving up on the top because all the water is moving all over underneath. Or not water, magma. So as everything's moving underneath, all these puzzle pieces are tectonic plates.
Tectonic plates?
Mm-hmm. They're floating on top of the magma. Okay? And so they're moving around along with everything. Okay? And these are crackers and frosting. Okay. So we're going to talk a little bit about how they come together to form natural disasters. Tectonic plates are like? Mm-hmm. They're like puzzle pieces.
Puzzle pieces.
Mm-hmm. Do they fit together nice, or are they sloppy?
You're sloppy.
Sloppy. They're definitely sloppy. Okay. So as these sloppy plates are moving around on top of the magma, they cover the whole world. They're bumping into each other, and they make natural disasters. So they bump into each other, they move apart, and they're sliding past each other. And we're going to talk about each of those. First one, divergent. So divergent is when you've got these two plates like this, and as the magma is pulling them apart, you got a hole, right? And the magma comes in between them from underneath, and it's going to sit right here on the bottom. Mm-hmm. And it's going to cool down, and then it makes a little valley. So there's a valley in between them. Mm-hmm. So that one is divergent. Okay? The other one, the next one, is called convergent. So if we try to push these together, if they're pushing in together, they're definitely not pretty. What's going to happen? Oh. What happened? What happened to it? They kind of smash and they break, right? One of them goes on top. The other one goes down below. See, like this right here. See how this piece kind of goes down? And this one is on top of it. So when they push together, yep, it makes a little dip right there. And that makes a lot of pressure in the magma over here, and that will make a volcano because it pushes all the earth up from underneath. There's too much pressure, so it's going and it burps up all the magma up. Okay? So that's convergent. The last one is transform. So transform, when they're sitting next to each other, so they're not moving apart, they're not moving together, they're moving past each other. See? So even when they move past each other, they still fall apart. Okay? And that's going to make earthquakes too, right? Because as they're moving, we're sitting on here with our houses and stuff, and it goes, and we can feel it shake as it's trying to move, right? So as we're moving, it makes an earthquake. sometimes it's only a little bit, and other times it's really big, and they're moving past each other. Earthquakes. Earthquakes. Okay, we're going to learn how to measure earthquakes. Does that work? Is that cool? Awesome. So if we're going to measure an earthquake, we're measuring its size. So we're going to call it a seismograph.
Seismograph.
Seismograph. Yep. That's how you can remember it. Seismograph.
Seismograph.
Yep, it measures how big an earthquake is. Okay? So we have our little National Geographic box over here. Totally appropriate. And I'm going to move these over. Okay. Do you want to be the earthquake or the seismograph?
The seismograph.
Okay. So this is what I'm going to have you do. When I say 1, 2, 3, go, I'm going to have you pull this paper through. Okay? So we've got our graphing paper on here. We're going to set up our marker so that it'll hit the paper. Okay? Nice. Okay. I think it's working. You ready for this? Okay. You ready? You're going to be the seismograph? Daddy's going to be an earthquake. Okay, we're going to do two times.
2 times.
Okay? You ready? Okay. So when I say go, you start pulling this through slowly, like this. Pulling it through slowly, okay? Okay, ready to be the seismograph? Okay. Ready? When I say go, you gotta pull this through slowly, okay? Ready, get set,
Go.
go. Okay, that was one. Okay. Okay, now we're gonna do a big one, okay? Ready, get set,
Go.
okay, all right. How'd our seismograph look? How's it look? Huh? Is it big? Okay, look. So this was our first one,
First one.
okay? Was this a big earthquake or a little earthquake?
Quick, little earthquake.
Big or little?
Big.
This one?
Little.
Yeah, that one is a little one. What was this one?
Big.
Big, yeah. See, look, you can count the squares because it's on graph paper. So you got 1, 2, 3, 4, 5. Some of these get up to like a 6 or a 7. This one only got about 2 or 3, so it's not very big. That's the same way a seismograph works in real life too. Okay, the seismograph, when the earth moves, it wiggles back and forth just like that. And it makes it so that you can see how big the earthquakes are. Is that cool? See all my markers? My marker prints from putting it on there? Yeah. Got thumbprints. You like your seismograph?
Oh, seismograph.
Yeah. Now we can measure earthquakes if they happen.
Earthquakes if they happen.
Right? Is that pretty cool? Okay. So, we're going to review real quick. Okay. Ready to review? Oh, thank you. Okay. So, we're going to review. Tectonic plates are like puzzle pieces.
Puzzle pieces.
So magma underneath circulates. When it gets hot, it goes up or down?
Up.
Up. And when it gets cold, it goes
Down.
down. So it's going like this all the time, and it moves the plates all over, and they bump, and they hit into each other, and they move away from each other. Convergent, coming together, smashing into each other, and they can make volcanoes. Divergent, they split apart, transform, and they're moving, bumping back and forth. And they can make volcanoes, earthquakes. And how do you measure an earthquake? Hey, how do you measure the size of an earthquake? What's it called? What's it called? A seismograph.
Seismograph.
Mm-hmm. Seismograph.
Grad.
Mm-hmm.
Glad.
Okay, you can say grad. Mm-hmm. Mm-hmm. Oh, thank you. Mm-hmm. It was kind of a simple one. Kind of a simple science. Thank you. Did you like this science? Was it kind of interesting? Huh? Okay. Oh, thank you. Oh, thank you. Convergent, divergent, transform. Making volcanoes, earthquakes, and you measure an earthquake with a
Seismograph.
seismograph. Good job. Did you like learning about tectonic plates?
Tectonic plates.
Makes lots of natural disasters. And now we have our own seismograph. Oh, thank you. Converge. Diverge. Transform. Converge. Diverge. Transform. Yeah?